Hi guys, welcome back to this video. In this particular video, we'll be taking a look at VRF aware VPNs. In this particular setup, what I plan on doing is taking a look at a couple of VRFs that are connecting my router, my multi-tenant router, router 1, which is connected to two different VRFs on the inside, VRF red and VRF blue. It is connected to the ISP using a VRF Lite setup where R1 has two interfaces towards the ISP. One is connected via VRF red 192.1.123.0. Another interface that's connected to the same ISP for a different tenant using an IP address of 192.1.145.0. What I plan on doing over here is setting up a DMVPN setup on router 1, but it's going to be segregated into the two different VRFs. One is the VRF for company red and the other one for company blue. The special thing about this is on the outside, when I do my normal IPSec, I need to configure my IPSec in such a way that it allows me the ability to look up my routes in the appropriate VRF. This type of VRF that is used to connect up on the public side, the outer header, towards my clients or the other devices is called a front door VRF, the FVRF. The inside VRF, which is towards the actual PCs, that is the actual VRF that the actual data devices are located at, is known as the internal VRF or the IVRF. So that's a concept that we're taking a look at over here. This overall concept is known as a VRF aware VPN. So first things first, let's take a look at our setup. What do we have over here? We have ISP, which has two interfaces connected towards router 1. Again, this is the physical topology. The ISP, I believe I have configured it already. Let's just take a look at the state. All right, let's just check. Show IP interface brief. Yep, it's got the different interfaces up and running. I have an interface connecting towards my router 1, which is E00, which is set up as 192.1.123.6, whereas my other side on this particular interface, show CDP neighbor, shows up as should be showing up as R1. Oh, I haven't done R1 yet. I haven't configured R1 yet. So I've done the other devices, but I haven't done R1 because I want you guys to do it based on, I want to show you how to do it based on the VRF. So router 1, the other devices I have configured, they should be up and running. They should have reachability towards the service provider. A default gateway towards 20.6. I should be able to ping 20.6. For that matter, I should also be able to ping 30.3, which is router 3 on the internet side. Router 3, same thing. I just want to verify that. Show IP route. And I should be able to ping 20.2 because that is going to be the other spoke on my DMVPN setup. And router 4, which belongs to company blue, I believe, let me just make sure. Yeah, company blue on the right hand side. Show IP route again over here. And as you guys can see over here, I again have a default gateway towards 40.4. This guy should be able to ping 40.5. Not 40.5, sorry. It should be 50.5, which is router 5. And router 5 over here, if I check this, should be able to ping 40.4. Good. So my topology is set up from the spoke side. On the server side, or the DMVPN headquarters site, it is not connecting. So what I'll do is I will go to my device and reset my console over here. There you go. Show IP route. It's a blank one. First things first, I'm going to create a VRF over here so I can assign the two interfaces E00 and E01 to the two separate VRFs. So VRF definition, call it red. VRF definition, we'll call it blue. So right now I have two VRFs in my running config. All right. I'll bring my two interfaces up, E00 and E01. The reason I want to do that, I want to make sure I'm connected to the right device. So I should have, eventually, once these two interfaces come up and I do CDP, should have two connections towards the ISP router. One of E00, which is locally connected to E01, and the other one is 11. Local interface E00, sorry, is connected to E01 and the other one is 11. So if you take a look at the ISP, which is E01, want to check the IP address on E01, which is going to be 192.1.123.6. So on my router 1, I am going to go to E00, make it a member of red, assign it an IP address of 123.1. Oh yeah, on the VRF, I need to, on red as well as in blue, I need to enable IPv4. I need to do the same thing for blue. I need to enable IPv4 as your address family. So now if I go back in, E00 is red and my IP address is 123.1. Something wrong. Interface E0/0. Ah, that's why. VRF forwarding red. IP address 192.123.1. No shut. Should be able to ping VRF red. Check the connectivity. .6. There you go. And for the default gateway, IP route VRF red 0000 192.1.123.6. So now I should also have connectivity towards ping VRF red to 192.1.20.2 or 30.3, my other devices. Alright. Similarly, I'll do the other VRF, which is VRF blue, which is E01, which interface on the other side should be 145, I'll call it .1 on this particular device. Again, VRF forwarding, blue, 145.1, IP route VRF blue, 145.6. So I should check the two VRFs. Try pinging this guy. I'll say 40.4. Oops. Don't forget, you need to put the VRF over here. VRF blue. There you go. 50.5. Good. Show IP route red. I have the default gateway over there, and again, full connectivity over there as well, 20.2 and 30.3. So my first objective, now that I have this up and running, now let's go ahead and set up my, my tunnel interface up. And I want to do it based on IPSec, basically DMVPN with IPSec. So let's set the red one up first, the one on the red, the left hand side. This portion over here between the VRF red, which is connecting 1, 2, and 3 to each other. I want to set up a DMVPN setup where R1 is the next hop server, the NHS, as well as acting as a routing hub for 1, 2, and 3. I want them to be segregated between router 1 red and router 1 blue. So we'll also create the loopbacks 10.1.1, both 10.1.1s, but in two different VRFs. All right. So let's go ahead and do that on router 1. Set it up as a NHS and a routing hub. I'm going to use EIGRP as my routing protocol to set this up. So let's go over here. create my loopback first. Loopback 0, let's say. VRF forwarding, let's call it red. 10.1.1.1. All right. Loopback 1, VRF forwarding blue. I'll also keep it as 10.1.1.1. but on two different VRFs. Now my tunnel interface. When I create my tunnel interface, I'm going to create it in Notepad or text edit. The reason for that is I want to be able to copy paste it on the next one. So interface tunnel, change the font to make it a little bigger. 24. Interface tunnel 1. VRF forwarding. We'll call this red. Alright, this puts it into the appropriate VRF. IP address. For right now, I'm just doing an MGRE tunnel. Then I'll go ahead and apply the IPSec portion to it. We'll say this is 192.168.1.1. My tunnel network. Tunnel source is E0/0. Tunnel mode is GRE multi-point. Alright. IP NHRP network ID. Enable NHRP on it. IP NHRP. We will set it up for dynamic routing. So map multicast dynamic. Alright. That takes care of that. I'm going to run EIGRP. So I want to do, let's say, phase 3. So I'll say IP NHRP redirect, but I also want to disable split horizon. I'm going to run EIGRP in, let's say, AS100. No IP split horizon EIGRP 100. Router EIGRP 100. And then no auto. Network 192.168.1.0. Oh, I need to do this under the address family. Alright. So before I do this, address family, IPv4 VRF red, autonomous system 100. Let me just stretch this a little bit. No auto, and the network statements now. Boom. So let's take a look at this. This is going to be my hub device. Let's check, see if it works. Looks okay on this side. Alright, so let's go ahead and run the same things on the other side. The other side, the spoke sites or the clients that you have, it's not going to be any different than what you would normally do. So for example, I don't have a VRF over there. I'm going to run it as .2 normal interface. I just want to make sure my interfaces are correct. Router 2. It is running it on E00. That's okay. This is fine. This is fine. But then I need to define my NHRP NHS, which is 68.1. How do I reach it? NHRP map. To reach 192.168.1.1, I'm going to go through 123.1. Alright, multicast is also going to go to 123.1. This is going to be shortcut. This is not required. This is normal because I'm not running it under an address family on this particular device. I already have a loopback, so let's see if it works. Line protocol up, and EIGRP should come up over here. Map multicast dynamic. EIGRP is up. Show IP EIGRP neighbors. No neighbors for EIGRP. Let's see if I can ping it. Oh yeah, on the hub side, there's one additional command that you need to put in under the tunnel interface, which is for reachability of the destination. Which VRF am I going to use for reachability purposes? Which is my tunnel red. This specifies how do I reach my front door VRF. Basically, what is my front door VRF so the tunnel reachability can be established. So one additional command that you need to do on the server side or wherever your VRF is at, this specifies what my data plane traffic is, what VRF is my data plane in. The tunnel VRF is basically for reachability of the tunnel destination. What VRF do I use to reach my destination? So that's where the tunnel VRF comes in. As soon as I put that in, my neighbor relationship came up on this side. Let's just bounce the interface. Oh, it had just come up, so there you go, neighbor relationship up on both sides. And I should have the routes from both sides. Okay, IP route, VRF red, EIGRP. 10.2 is learned. So almost everything the same as what you would normally do. The only thing is because my outside, the reachability for my tunnel destinations is through a VRF, I need to specify what am I using for my front door VRF. What VRF am I using to reach my tunnel destination? That is known as the front door VRF. I need to define that with the tunnel VRF command. So if you want to write a note over here, it's basically specifying the reachability of the outside header of your tunnel. What VRF am I using on the outside? Because I don't have any global routing, I'm going to use a specific route, specific VRF to reach that. Whereas the VRF forwarding is for the actual data traffic that's going through it. That's called the internal VRF. So this, in my case, they're the same, but they could have been two different VRFs over here. On the other side, on the other spoke that I have, it's almost going to be the same. It's router 3. And everything else points towards the server. So I can just copy paste this onto router 3. Oops. Okay, copy was not proper. Copy. There you go. Router 1 pops up. Show IP route, VRF red, and I'll just do EIGRP just to make it like that. If I go to router 3, because I'm doing phase 3, trace route 10.2.2.2, source 10.3.3.3, first one through the hub, and then I'll get the redirect and the shortcut working, and then I'll go direct. Good. Once this is done, then I can go ahead and do my IPSec on top of it. But before we do that, let's go ahead and replicate that for the other VRF, which is VRF blue. So if you go to router 1, I have my interfaces already set up as part of the VRF, which are my E00 and E01, and I have the loopback 0 and loopback 1 also configured. So now let's go ahead and set up my second tunnel. If I want, because they're in two separate VRFs, I could potentially keep the same network address, but just to make it a little bit easier to understand, I'll specify a different IP address. And again, my front door VRF and my IVRF are blue. So 2.1, E01 is my outgoing interface, the rest remains the same, and this will change to 2. And I'm keeping the same address family but a different VRF. I can keep the same, same, what do you call it, autonomous system. So copy this, Oh yeah, one very important thing, make sure it's tunnel 2 because I already am using tunnel 1 for the other stuff. Copy it, go back to router 1. My tunnel 2 is up. I just need to configure the clients now. On the client side, oh well, go to router 2 and check my tunnel. Copy this and change it. Tunnel 1 on the clients doesn't matter because it's different clients. 2 dot will say 4. This is going to be on router 4. NHRP 2.1 is 145.1. Map multicast to 145.1. NHS is 2.1. So that is done. This is done. And now router EIGRP 100. No auto. Network is 2.0. So this is on the client side. So this is router 4, which is the second client for the second tunnel that we have, the VRF blue on the headquarter or the multi-tunnel headquarter. 2.4, 2.1, 145. Network ID can be the same or it can be different. Just keep it different because we're keeping these two tunnels with different setups, or it could be the same. It really doesn't matter because this is on the client side. Copy. Boom. So the tunnel is up and my EIGRP should also come up. There you go. So if I go to router 1, show IP route VRF blue now. And we'll just do it for EIGRP. 10.4 is popping up. We'll do the same type of setup on router 5. Just change the IP. The rest of it all points towards the server. So that can remain the same. Copy it. Go to router 5. Paste it. And now if I go to the hub, I have 10.4, 10.5. Again, if I go to 10.5, do trace to 10.4.4.4, source 10.555. Goes direct the first time around. Oh, sorry, goes to the hub the first time around. NHRP shortcut goes direct. The last thing that I need to do over here is I need to do my encryption of the tunnel. That's where the VRF aware IPSec VPN comes in. So how do I do that? Let's go ahead and do that in Notepad as well because I'm going to copy paste it. Step 1, do it like this. Step 1, configure phase 1 parameters. How do I set this up? Crypto ISACamp policy 10 auth pre-share #MD5 group 2 encryption triple des. Now when I create the key is created a little different over here. Crypto keyring, let's call it red, VRF red. Okay, here you specify your pre-shared key as for address 192.1. or yeah, this is going to be 0000. Key is Cisco. The reason for that is I want to keep the common, create a common key on the hub for all the clients. Let's just make sure this pops up. There you go. My keyring is done. That's phase 1. In phase 2, Step 2 is configure phase 2 parameters. What are my phase 2 parameters? Crypto IPSec transform -set ESP triple des ESP MD5. Step 3, configure your an IPSec profile and link the transform set to it. CRYPTO crypto IPSec profile. Just call it ABC, send transform -set ABC. And the last thing, apply the profile to the tunnel interface. Another thing that I would generally do, because I'm running GRE and IPSec together, I would change the mode to transport. So over here, how do I apply it? Tunnel protection, IPSec profile ABC. That should do the encryption. I've done this part already. Copy this onto router 1. Now the tunnel will go down for EIGRP and all that type of stuff because one side is encrypting it, the other side is not. So I need to do the same thing on the client sides. So for the clients, I don't need to worry about creating a keyring over there because I'm not doing VRF aware on the client side. So on one side I am, on the other one is not. So on this side I can just do a normal crypto ISACMP key command, Cisco address 0000 for all the keys. The rest remains the same. So I can just copy this and paste it to 2 because right now 2 and 3 are both down. That's 2. ISACMP is on. Should set it up. The tunnel should come up. Same thing on 3. Should pop up. Alright. Now if you go to router 1 now, show crypto IPSec SA. There you go. It is sending the packets towards 30.3. Packets are encrypted, decrypted. This is a VRF aware VPN. If you take a look at the protected VRF is red over here. There's another command that you can do, show crypto IPSec sessions, I believe, or crypto sessions SA. Yep. Sessions details actually shows you that you have 2 VRFs, the front door VRF and the inside VRF. The internal VRF is both set to red right over here. Okay. Now over here on router 2, if I do the same command, it's not using any VRFs, so it's going to have no VRF for front door, or it's just using the global routing table for reachability as well as internal. If you want to take a look at the internal VRFs where you want to segregate them as well without having a front door VRF, I have the other videos that show that. Alright, just to complete this whole thing, I need to do the same thing if I want to encrypt the second VRF. So basically, if you take a look at it, for router 1 again, I'm going to do the same. I don't need the policy again because I'm going to use the same policy. Oops. But I do need to create a separate, because it's the same router on router 1. I am going to create a separate keyring, which is going to be called blue, which is for the blue VRF. And if you want, you can use a different key for that. Cisco, let's say 145, just for the heck of it. The rest remains the same. I'm going to apply the tunnel interface and my tunnel will come down until I go ahead and do the other side. So over here, oops, there's certain issues over here. Blue should be like that. Blue, Cisco 145, just remember that we need to do it on the other side as well. I'll go back to router 1. Oh yeah, one more thing. that I would need to change is this guy. I can use the same, what do you call it, phase 2 parameters as well. So on router 1, I don't need this. I don't need this. I just need to apply the profile to the second interface. So the only thing that I did, because I was using the same parameters, is create a separate keyring because my phase 1 and phase 2 parameters predominantly are the same. I'm using the same profile. Just go to the second tunnel and apply it. So this is all I need actually, because the rest of it is there. Now again, the two neighbor relationships for EIGRP will go down on router 1. For the there you go, 4 is down and 5 is down. 1 and the other one will remain up. It's for that particular VRF, so my neighbors should be up on 2 and 3. These guys are okay. It's just the 4 and 5 are down. How do I bring 4 and 5 down? On the client side, because I'm doing it from scratch, I do need to keep all these parameters intact. The interface I believe on these guys is tunnel 1. I just want to make sure that it is tunnel 1, so I can keep it. So all these parameters are still the same because I'm using the same parameters on the hub site. If I want to, I could have changed them, but I kept them the same. As soon as I apply it, my tunnel should come up. And oops. Something wrong in the way I set this up. Let's just check. Oh yeah, the password. This guy, I kept it as 145, so I need to take on router 4. No crypto, IPSec key Cisco address 0000 and put it in as 145. That should bring it up. There you go, the neighbor relationship is up. If you remember, I had changed the password over here to Cisco 145 and the other one was still set to the same one. So on the other spoke on this particular setup, which is, did I change it over here? Yeah, 145. So if I go back to router 5, the last spoke on the second VRF, second company blue, bring it on, should bring the tunnel up. There you go. So now again, if I do my go to router 1, my tunnel's back up, show crypto, sessions and detail, I would have multiples. I have 2 tunnels up, tunnel 1 active with the front door and the internal VRF being red, and then tunnel 2 which is blue. Okay, show crypto IPSec SA, and there you go. There's a red that is having packets in there, and there is another one that should be blue. There you go, tunnel 0, tunnel 2 which is blue, protective VRF is blue, and this is called your front door VRF or VRF aware VPNs. I hope you guys enjoyed it. Till next time, best of luck.